yeah, let's just finish doing the 3D bouncing ball. I guess the next thing I want to do is a one-legged unstable walking blob. The reason I want to show you this kind of exercise is because when you're animating something, it's gonna be a here we are. When you're animating, I said that you were supposed to be creating transitions between physical states, which means you're essentially simulating, you're doing a physics simulation in your head. So I mean, one good example of physics simulations, if you look at a lot of video games, a lot of modern day video games, they have Havoc physics simulations, they've got ragdoll simulations, and this means imagining how an object would behave in real life. An object with mass, which is affected by gravity, is affected by Newton's 3 laws of motion, how these things behave, and showing how there's an exertion of forces on masses, and a lot of animation relies very much on a physics simulation. So yeah, that's why I think this exercise is going to be pretty good. It's an unstable blob on one leg, an unstable one-legged blob. So I'll do this one as a 2D, do this exercise as a 2D one, because you're just trying to get a sense of both mass and exertion. So when I start this exercise, I prefer to draw the blob up in the air, and actually I'm going to move it even higher. It's going to be slightly out of the frame. And yeah, let's make it fall. So similar to the bouncing ball exercise, except yeah, let's have it fall. And I'm not exactly sure where. You need something, right? So having those first few lines is kind of handy. Don't try to draw like a perfect ball. There we are. And maybe I might even have it like kind of banging against some kind of surface, just because I want the I don't want it to just fall straight down. I do want it to be off at an angle. So wham, right? So I'm just redirecting. So we look at that, right? You should be able to look at this and sense the motion. Right? How does it feel, right? And if it doesn't feel quite right, then ditch the drawing and make an additional one. So I think this one, it's good. I like the feel of it. I just think it needs like maybe some additional in-betweening. So maybe more of the moosh. I need more mooshing. Okay, good. And like I said, it was going to be a one-legged blob. So right now I'm just drawing the blob, and I'm going to try and get the blob to kind of steady itself out. And if anything, it's steadying itself without any legs or anything. The leg comes afterwards, surprisingly. So, right, I just kind of want it to I want the blob to come down and come up maybe a bit, and hop around a bit while it tries to stabilize itself. Yeah, I'm not quite feeling that. I don't feel that that's very. That's much better. Yeah. And then maybe I'll have it kind of hop in the air briefly. Great. Okay, so there's our unstable, and then I'm going to have it fall back down and settle. So up and then. Yeah, I've noticed that as I do this, right, there's the direction in which something's traveling. I tend to like to encapsulate the end and the beginning, but I need the flow first. So flow would mean that as an object travels, there's a flow that it goes through, and I like to encapsulate, along that flow. So, bop, and then maybe I'll just have one more frame where it kind of goes bop. Bop. So, bop. Good. So it doesn't have all of its in-betweens, but let's so it kind of banks off of this thing. And here, let's just get that one leg in there. Have it scooching. Screech. Right, it's kind of screeching to a halt. So I'll just I'll throw on a light table just so I can see the previous frame. Great. Okay, I'm liking the look of that. And yeah, so I'm just have some compression of the leg. And now I can have some of these lines boil up. Yep, there we go. And this is the contact point on that sphere, so I'm going to try and keep that over there. Let's try and keep the same contact point. And let's let the foot, all right, let's let that toe plant. I'm still boiling up these little fragments. Oop. Oh yeah, and let's look. I'm gonna flip through and look at the rest of these little fragments. Let's just do little pieces. They're almost completely done disintegrating. I don't have to even show all of them. I think I'll put one more disintegration frame on that guy and that one. In fact, okay, if that's where the contact point is, I'm gonna reverse the leg just a bit. Let it hop into the air. And then let it reposition. So now the foot's gonna, right, in order for that foot to catch itself, it has to land underneath. So you need this bit of a frame up here, right? So the only time I can lift the leg is when the weight is off the leg. So I can only do that when the body mass is up in the air, right? And the body mass is traveling upwards. This is the only time in which the foot can be off the ground. And then bam. And so I think I'm going to move the contact point to about here. Bam. That seems legit. Boom. And let's throw in some more frames. So I feel like I can put it in between here, between these two guys, so let's do that. Okay, so I know it's going from top to bottom, so I'm going to try to do the same thing. I'm going to establish flow. Let's get the flow. Just make sure it's traveling in the right direction, and then encapsulate afterwards. And I'm going to put let's do the foot first, and then I can figure out how the leg is going to the contact point of the leg's here. So if you know where the contact point of the leg is and you have the orientation of the foot, then it limits the number of possible positions for the leg to be in. So it's like it's almost like a system of inverse kinematics. You might want to look that one up on Google. Inverse kinematics. It is a technique of handling joint animation for 3D software, and it's based around this. Basically you've got end effectors and whatnot. Yeah, look that stuff up. It's you might find it helpful. Boom. So let's scrub through that. Boom. Okay, good. So now that I have that, let's go to the next frame. So I imagine that this leg, knowing that this is the contact point and that's where the heel is, right? That you now essentially have a coiled spring between there and there. That means that any amount of exertion is going to move, it's going to apply that much force to this sphere. We also know that the sphere is traveling down and it's kind of going in this direction, right? It's got a velocity. Its net velocity is this direction. So that can only, to me, this makes me think that the motion is going to go up like that. So, I mean, you just, as you flip through it, right, you get an idea for a sense of the flow. In fact, hey, draw it if it helps, right? And there There we are. And then you can encapsulate, right? Get the flow and encapsulate. And I'm going to draw the contact point. Boop. I'm going to draw that foot. That foot cannot move because right now there's weight is being exerted on that foot. The foot is being rooted to the ground because there's exertion being applied. This knee joint is uncoiling. So is the hip joint, so is the ankle joint. All these things are forcing. They're forcing the leg. They're forcing that leg apart. They're pushing back. There's exertion going on. And so the foot is being rooted. See how that looks, right? Pretty good. Not bad. And I'm gonna just neaten up. I'm gonna neaten that up a bit. Boom. Yeah, that's better. Now, if you're drawing, actually no, not if. When your drawing becomes too cluttered, and it will get cluttered, make sure you have a nice big fat soft eraser and just tap on the thing. Don't completely obliterate your drawing. Leave behind a few lines. In fact, I might undo, right? You can leave, just knock it back a bit, knock back the opacity, and then redraw. Just keep on being, keep up the poopy drawing. It doesn't have to be clean. But, the key thing is that you're just knocking everything back, and then you're going to reinforce the lines you want to keep. So, yeah, when your drawing becomes too cluttered, and it will become cluttered, just knock it back. Okay, so let's get that flow again. And then encapsulate. Good. Find that contact. Find the hinge point of that leg. And so now I'm going to completely stretch that leg out. I feel like there's a huge gap between these two stages, so I'm just going to throw in an in-between. Feels like it needs it. So what I don't do is I don't try to make this huge time chart and all that stuff. I look at the most important keyframes. I look at where the keyframe flow goes. I do my animation as necessary, and then I might make some frames last longer and other frames last not so long. If I need to adjust the timing, I go up here and I start adjusting the length of the frames. Until I fill up the allotted amount of time. But this kind of motion, it gets me the best motion. And so I use the flow to figure out where things should be going. What's the three-dimensional pathway they should be traveling through. Then I begin encapsulating, to work out my spacing. And it's very efficient. It's very, very efficient in that I have no wasted drawings, and it means that you get the basic gist of the motion, and you get all your spacing, and you get your timing all in one go. It's a very I don't know, it feels like a very organic process. So here I'll just, now in this case, I'm going to rewind this, right? If you rewind the animation, well, frame by frame, right, you can kind of sense, right, where that foot's going to go. And I can rewind back again and find out where that contact point is. And we're going to bend the leg back a bit just for the sake of stylization. All right, look at that. And then at this point, I'll throw in... See, now... So the thing is that when you're in-betweening, you're doing interpolation. This means that you have two data points. And actually, they're not just data points. They have maybe a tangent to them. All right? So you have these two data points, and you're figuring out what's the in-between of those to connect them. What's the smoothest in-between you can put in between those two data points to connect them? So when you're doing whenever you're doing in-betweening, you're interpolating. You're interpolating between the previous frame and the next frame. In this case here, I am now... Right? I'm at the end of my animation. I'm still going forward. I'm now extrapolating. But when I extrapolate, I can look at the previous frames beforehand and figure out, well, you know what? Chances are, look at this motion, right? Look at this motion as you scrub through it. It's very likely that it's just going to go... Look at that. It goes down and then up, so it's probably going to go like that. That's what I sense. So go in there, throw in that blank frame, and yeah, roughly, draw in the entire curve. Don't worry, you can knock back the stuff you don't want to keep. Draw the entire flow, and then encapsulate. Bam. Great. Okay, good. And then throw in the next frame, right? Like sometimes it's easier to track a single object, right? Meaning just animate that one piece and then go through on another iteration and then put in another piece and go through another iteration, then put on the next piece. Like build it up, right? So you see how that works, right? So build that flies back. Good. Now I'm going to track the track the attachment point of the leg. So I think it's about here. I'm going to track that. So there's that little X. Okay, good. Now that I have that little X tracked, I can use that as a basis to figure out where the leg goes. Maybe it's a little too long, but let's see how that feels. That feels pretty good. Okay, good. Now here I need that leg to catch. I think at this point the leg will probably be, probably back here now. Right, so this is the unstable. This is why I say it's an unstable one-legged blob. Right, so that's going to catch like that. Obviously, we need an in-between here, so do the same thing. Throw in your in-between between here and here. Look at the flow, right? Get your flow established. Encapsulate, right? Encapsulate the before and afterwards, and then look at this foot position, right? Look at how that has to snap quite far. So let's see. I imagine the motion's going to be like that. Right? And just like I haven't even drawn the whole foot. I've just drawn a path that the foot takes. Somewhere along there is the foot. I think it feels like it's going to be about here. Great. Get that attachment point in there. In fact, I think I might I'm going to reverse the foot. Right. Good. So now it's toe down. And then knee forward, toe down, like that. Great. Let's see. Yep, seems legit. All right, good. And then just continue with the follow through of this blob. And so it's here. This is our final frame. This is as far as our animation goes. We're at the end of the animation. So same deal. Keep on going. Extend the flow. Be light, and then encapsulate, and get the attachment point, get the foot position here, and I don't know if he can recover from this. I don't know. It looks kind of unrecoverable, which is fine. I mean, like that's just what happened that's just, how this plays out, right? That's the way the simulation runs. But I mean, what I could do is in this case, here, let me undo that. If I want him to catch himself properly, then the foot will land here, and I think the ideal position for the foot to properly recover from that is to put it here, and then get the knee joint in there, then extend the ground and skid that. See that? How the foot slides. Do a foot slide. Right? Look at how that foot slides. So that's how I manage the recovery, is let the foot slide. And great. And then once again, we're back. We're extrapolating. So same deal. Get your flow going. Get your flow on. I think it'll probably be around here. Yeah. Get that contact point. Get that foot, and then do the inverse kinematic. Boom. This stuff's like really, it's when if you this way is the easy way, right? I'm not going to say this is the way to do it, or it's my way, or whatever. I say this way is easy. This way is easy, and animation is generally very difficult. And if you want it to be difficult, it can be difficult. If you want it to be easy, here's an easy way. So great, up, and I'm going to make this blob catch. It's an unstable blob, right? It's got a leg on one side. It's highly unbalanced. So I mean, you can just keep that leg hopping forever. I can see that foot, so I'm going to peel that foot off. And catch once more. So I just see like this foot, coming up, and I imagine it's going to come down here. Sure, why not? And let's looking at this main mass again. I feel like bam. Okay, so here there's an in-between. I think I need another. Yeah, I need an in-between. So here, sometimes, you know, it's like it's let's get that attachment point. So the attachment point's here. That means tracking the attachment point. So I think about here, I can probably, I'm going to bend the leg backwards just to kind of show how it, right? That backward bend, right? It really shows a snap. It's boop, boop, right? It's a bit of a trick. So let's, I'm going to turn off the light table and just flip through that. Let's see how it looks at 24. Okay, it's too fast. Let's try 12. All right, so there you are. This is what I meant by it being a physical simulation. It's a physics simulation. A great way to get into animation and getting into the idea of simulating physics. And hey, it's fun. So yeah, that's I guess that's long enough. This video is long enough, and I'll do another one.